In the 1950s, every major American railroad was scrapping steam and buying diesels. The math was overwhelming. Diesel was cheaper, cleaner, and easier. Except on one railroad. The Norfolk and Western looked at the same math everyone else did and kept building steam. Because the Norfolk and Western had engineered a steam locomotive that could compete with diesel on the one thing that mattered: cost. This is the Class J, built entirely in the Norfolk and Western's own Roanoke shops. And what was under its streamlined casing was the most refined passenger steam engineering ever produced in North America. This is the steam locomotive that refused to lose to diesel, and the engineering that made it possible. Not the biggest, not the fastest, the best engineered. The Norfolk and Western was unusual among American railroads. It hauled coal, enormous quantities of it, and it built its own locomotives in its own shops in Roanoke, Virginia. It was not dependent on outside manufacturers, and it had a financial reason to keep burning the coal it carried. When the railroad needed a modern passenger locomotive, it did not buy one. It designed and built the Class J in-house, starting in 1941. The result was a locomotive that combined the streamlined styling of the era with engineering refinements that most American steam locomotives never received. The Class J was built to a standard of precision that let it run further, faster, and with less maintenance than almost any steam locomotive in America. It was the Norfolk and Western's answer to the diesel, and for years it was a convincing one. The single most important engineering choice in the Class J was the use of roller bearings, not just on the axles, but throughout the entire running gear, including the rods. Most steam locomotives used plain friction bearings, which required constant lubrication, generated heat, and wore quickly under load. The Class J used roller bearings on every axle and on every rod joint. This dramatically reduced friction, reduced heat, reduced wear, and reduced the maintenance the locomotive required. A friction-bearing locomotive needed frequent stops to inspect and re-oil the bearings. The Class J could run for far longer between servicing. The reduction in friction had a direct performance benefit. Less energy was lost to bearing friction, which meant more of the boiler's output reached the rails. The Class J could accelerate a heavy passenger train quickly and hold high speed with less effort than a friction-bearing locomotive of similar size. The rods themselves were engineered for balance and precision. A steam locomotive's rods and wheels must be carefully balanced, or the reciprocating masses produce a hammering force on the rail at speed. The Norfolk and Western balanced the Class J's running gear with a precision that allowed sustained high-speed operation without the dynamic augment that plagued less carefully engineered locomotives. The Class J was capable of running at over 100 miles per hour. It was tested at speeds that demonstrated it could hold passenger schedules faster than the railroad's routes actually required. The precision of the running gear was what made those speeds safe and sustainable rather than dangerous. The locomotive also used a comprehensive mechanical lubrication system that automatically delivered oil to the points that needed it. Combined with the roller bearings, this meant the Class J required far less hands-on maintenance attention than a conventional steam locomotive, which was central to its ability to compete with diesel economics. But precision running gear was only part of the story. The Class J also had a boiler engineered to feed those precision rods with everything they could use. The Class J used a 4-8-4 wheel arrangement, 4 leading wheels, 8 driving wheels, 4 trailing wheels. This is the classic northern configuration, chosen by many American railroads for high-speed passenger service because it balanced power, speed, and stability. The Class J's boiler operated at 300 pounds per square inch, a high pressure for an American steam locomotive and higher than most of its contemporaries. The high pressure gave the locomotive more energy per unit of steam, improving both power and efficiency. The firebox was large and fed by a mechanical stoker. The boiler was engineered to sustain the high pressure continuously, feeding steam to cylinders that could keep a heavy passenger train moving at high speed on the Norfolk and Western's demanding, curving mountain routes. The Class J used relatively modest driving wheel diameter, 70 inches, smaller than many high-speed passenger locomotives. This was a deliberate choice. The Norfolk and Western's routes were mountainous and curving, not flat and straight. Smaller drivers gave the Class J more tractive effort for climbing grades, and the precision engineering let it still reach high speed despite the smaller wheels. This was the genius of the Class J's design. It was optimized for the actual railroad it ran on, the mountainous, curving territory of Virginia and West Virginia, rather than for the flat, high-speed running that other passenger locomotives were built for. The smaller drivers, the high boiler pressure, and the precision running gear combined to produce a locomotive that could do everything the Norfolk and Western's passenger service demanded. The Class J produced approximately 5,000 horsepower and around 80,000 pounds of tractive effort. These were strong figures, but the numbers alone do not capture what made the locomotive special. It was the combination, the power, the precision, the low maintenance, and the reliability that let the Class J compete with diesel. The streamlined casing that gave the Class J its iconic appearance was also engineered for practicality. It could be opened for maintenance access. The styling was designed by the Norfolk and Western's own people, not an outside industrial designer, and it balanced appearance against the reality that the locomotive had to be serviced regularly. Could a steam locomotive in the diesel age still make economic sense? The Norfolk and Western tracked the Class J's performance obsessively, and the numbers were remarkable. The Class J achieved availability figures that approached diesel levels. The locomotive was ready for service a high percentage of the time, thanks to the roller bearings and the low-maintenance engineering. The Class J routinely ran enormous distances between major servicing. Some Class J's accumulated 15,000 miles per month in regular service, figures that most steam locomotives could not approach, and that rivaled diesel utilization. Because the Norfolk and Western hauled its own coal, its fuel costs were low. Combined with the Class J's efficiency and low maintenance, this meant the railroad could operate the Class J at a cost that was genuinely competitive with diesel. For a railroad sitting on top of its own fuel supply, steam still made sense. The Norfolk and Western was the last major American railroad to dieselize, precisely because its steam locomotives were engineered well enough to compete. The Class J, along with the railroad's other modern steam classes, kept steam economically viable years after other railroads had abandoned it. The Class J hauled the Norfolk and Western's premier passenger trains, the Powhatan Arrow, the Pocahontas, the Cavalier, through the mountains of Virginia and West Virginia. It was the face of the railroad's passenger service and a point of genuine engineering pride. But economics eventually caught up, even with the Class J passenger traffic declined across America in the 1950s as automobiles and airlines took over. And as the national supply chain for steam locomotive parts and expertise withered, maintaining even a superbly engineered steam fleet became harder. The Norfolk and Western finally dieselized at the end of the 1950s. 14 Class J's were built between 1941 and 1950. As dieselization arrived, they were retired. Most were scrapped, but one survived, number 611. Number 611 was preserved rather than scrapped. It became the centerpiece of the Virginia Museum of Transportation in Roanoke, the very city where it was built. For years, it was a static display, a monument to the railroad's engineering, but the Class J was too well engineered to stay still. 611 has been restored to operating condition more than once, and it returns to the rails for excursion service, drawing crowds wherever it runs. The precision engineering that made it competitive with diesel in the 1950s is the same engineering that makes it restorable and operable today. When 611 runs today, it demonstrates exactly what made the Class J special: the clean exhaust, the smooth high-speed running, the precision of the roller-bearing drivetrain. It is one of the finest operating steam locomotives in the world, and it runs the way it does because of engineering choices made in Roanoke over 80 years ago. The Class J is a different kind of engineering story than the extreme locomotives. It did not push scale like the big boy or pursue radical technology. It pursued refinement, taking the conventional steam locomotive and engineering it to a standard of precision that let it compete in an age that had supposedly moved beyond it. The Norfolk and Western built the Class J in-house because it believed a well-engineered steam locomotive could still earn its place. For years, it was right. The Class J was proof that the death of steam was not purely a matter of technology. It was a matter of how well the technology was executed, and the Class J was executed better than almost anything else. What is under the Class J's streamlined casing is not raw power or radical innovation. It is precision. Roller bearings, balanced rods, a high-pressure boiler, and relentless attention to reliability. That precision is why the Class J could beat the diesel on cost. And why, of all the locomotives in this series, it is one of the few still running today. The Norfolk and Western Class J611 is the most refined passenger steam locomotive ever built in North America. It proved that steam, engineered well enough, could still compete with diesel, and it did so because of precision, not power. This is part 5 of our What's Under the Hood series. The first 4 covered the Big Boy, the GG1, the F unit, and the K4. All are linked in the description. Next, we cover the EMD GP38-2 and SD40-2, the diesels that descended from the F unit's engine and became the most successful locomotives in American history. The machines that finished the job the F unit started. Subscribe so you do not miss it. There is more American railroad engineering to explore. Each of these locomotives deserves a full mechanical study, and we are working through them one at a time.